In this video, I'm going to talk through how we can use dimensional analysis to solve problems where we're working with cubed quantities. So in this case, we're going to do centimeters cubed to inches cubed, and then we'll also do a density example at the bottom. To start with, up here, I have the same process that we've been working with in the previous videos. So first, I identify the thing that I'm looking for. Then we have the quantity that's given to us, and then we have a conversion factor. Also here in the equivalent statements, I have a milliliter is equal to a centimeter cubed. This is a conversion factor you should have memorized. This is one that we use a lot when we're working with density. You'll see grams per milliliter and grams per centimeter cubed used interchangeably. The 100 centimeters to equal to 1 meter, that's also one you should have memorized. That 2.54 centimeters equals 1 inch is one that I will provide to you if you need it on a quiz or exam. So let's jump right into this first problem. So we're converting 543 centimeters cubed to inches cubed. So we do our normal setup. I'm looking for inches cubed. I'm starting with 543 centimeters cubed. So we then have a conversion factor. I'm trying to go from centimeters cubed to inch cubed. So if we look up at our equivalent statement, we have this one here, which takes us between inches and centimeters. That's not the same thing as inches cubed and centimeters cubed, but we can use it. So we don't have anything given there that connects me directly between centimeters cubed and inches cubed. So let's use this one. I have 2.54 centimeters equal to 1 inch. Then when I go to see if I can cancel, I'm looking at this centimeter and this centimeter cubed. And if they're not exactly the same, then I can't cancel them. So we want to remember that centimeter cubed is really a centimeter times a centimeter times a centimeter. So this centimeter, this will cancel with one of those centimeters. Not all of them, just that one. So if I want to cancel those other two, I need to plug in two more of these conversion factors. So they're the same ones. 2.54 centimeters is 1 inch. And now this centimeter will cancel that one, this centimeter will cancel that one, and I've gotten rid of all three, so that centimeter cubed is canceled. The units I have left, I have inches times inches times inches. Doesn't really look like an inches. Inches times inches times inches, and so that leaves me with inches cubed, which is what we're looking for over here in our starting spot. So this is a long expanded way to do this problem. I can do it in a shorter notation if I set this up again. So we are looking for inches cubed. We still have this 543 centimeters cubed. And then I can take this first conversion factor with the centimeters and inches, and I can just cube that whole thing. Because really all I did here was take this times this times this. So I multiplied it by itself 3 times. If you do this, you want to just remember that that 3, that exponent applies to everything on the inside. So I have to do 1 cubed, inches cubed, 2.54 cubed, and centimeters cubed. So when you plug that into your calculator, just be careful, make sure you get all of those numbers in there correctly. When we have that, we have centimeters cubed will cancel centimeters cubed, just like above. This, because of that cubed on the outside, is inches cubed, which is what we were looking for. So we're in good shape. We can plug this into our calculator, either one, and we're going to end up with 33.135. We do need to check sig figs, so there's 3 here. I'm going to keep those 3 spots. The next three tells me I don't need to round, so we get 33.1 inches cubed as our answer. The next example, we're going to work with density. And so density is a physical property that involves a ratio of mass to volume. So the units for density are a unit for mass over a unit for volume. So often we'll see grams per milliliter or that grams per centimeter cubed. An important thing to notice, when you see a quantity that has units that have a ratio in the unit, we can write that as an equivalent statement. 1 gram equals 1 milliliter. Or we can put this as a conversion factor, 1 gram per 1 milliliter. Okay. One thing you do not want to do is do gram per milliliter over milliliter or something like that. When you have that ratio in the unit, you want to make sure and split it up. Put the thing on the top and put the thing on the bottom on the bottom. It will make your life much, much easier when doing these calculations. So for this one, we're going to set it up like we've been doing everything else. We are looking for density of water in units of kilogram per meter cubed. So just like I just outlined up here, if I'm looking for kilograms per meter cubed, I'm going to write this here with kilograms on the top and meters cubed on the bottom to really emphasize that I have a top unit and I have a bottom unit. Otherwise, we're going to set it up the same way. I still want my units on this side over here to be the same as the units over here. So this is my goal. Then here in this first spot, we're going to put that 1 gram per milliliter. Right, we put the gram on top and the milliliter on the bottom. And then we're going to do conversion factors. So this one's a little bit different because I have more than one set of unit that I'm trying to switch to, right? So over here, I have kilograms and I have meters cubed. So on this side, I'm trying to get rid of the grams. I want those grams to get changed into kilograms, and I want those milliliters to get changed into meters cubed. So I'm going to have multiple steps that we're going to take to make this happen. So let's start with the grams to kilograms. So I have grams here. You guys should know this conversion factor, that there's 1 kilogram equal to 1,000 grams. That is one you should have memorized. When I do that, my grams can go away. So those have been canceled, and I'm left with the kilograms. So I have kilograms on top. That's what I wanted. So on top, we're good. But I still have those milliliters on the bottom, and I want to convert those into meters cubed. So I need to set myself up another conversion factor. And the milliliters here are on the bottom. So if I want to get rid of them, I need to put those up on the top. So I know those are going to need to go here. Let's check up in our equivalent statements to see if we have anything that goes directly from milliliters into meters cubed. And if we look up here, we don't. We do have this one, which can take me milliliters to centimeters cubed. And then I can, of course, get from centimeters to meters if I cube that relationship there. So we'll do this in 2 additional steps. We have 1 milliliter is equal to 1 centimeters cubed. So that milliliter on top cancels that milliliter on the bottom. I have centimeters cubed on the bottom. I still need meters cubed, so I need another step. Here's my other step. I have 100 centimeters, and then I've got 1 meter, and I'm going to cube that one. When I cube that, then this centimeter cubed is going to cancel this centimeter cubed, and I'm going to be left with my meters cubed, which is what we're looking for. So we're going to go ahead and stop here. We have everything we need. I've got those kilograms on the top, and I've got the meters cubed on the bottom, because remember that cube on the outside of the ratio here applies to everything on the inside. So kilograms on top, meters cubed on the bottom, which is what we're looking for. Plug all of that into your calculators, and we're going to end up with 1,000 kilograms per meter cube. Check our sig figs real quick. We only had 1 to start with. We only have 1 here at the end. Make sure we've got the correct units, and you're all set.